So good day everyone. I am Sir Aldrin Murillo and we're back and I am about to discuss the module 6 of this course Basic Calculus in SERTS, which is actually entitled Applications to Derivatives, but we have three main parts of this discussion. First part being the optimization as an application of basic calculus particular derivatives. The second part is the local linear Second part is the local linear approximation, and the third part is the related rate. And third part is the related rates. Each of these three main parts will be discussed differently across this week. So hope you stay tuned until the end so that you will gain a little bit of surface level knowledge that I think I could help you in learning about derivatives. So let's get started. Optimization in literal context means the action of making the most effect on use of a situation or a resource. So, maiisip na natin na ang optimization, by this part pa lang, makita natin na like, ito yung process ng pagpapalaki or pagpapaliit natin ng bagay depending sa situation. Kung di natin mapalaki yung isang bagay to the maximum level it possible, we are optimizing it. And if vice versa, we are minimizing it, we are also optimizing it. In mathematics, particularly calculus, optimization is the process of finding the maximum and minimum values of the given constraints using the concepts in calculus. So it is finding the maximum or minimum value of a certain function or situation using derivatives. So let's just define some terms. A constraint function is a function that can be transformed into a different form that is equivalent to the original equation also. So parang ito yung equation na pwede mo manipulate with still having the same values pero iba na yung form. An example of which is 2x plus y equals 30, which also can be written in negative 2x plus 30 equals y, which further can be written in the form 2x plus the quantity negative 2x plus 30 equals 30. So mapapansin natin na nagkaroon na yung original function or equation is in two variables which is x and y, pero nagkaroon tayo ng chance na ma-manipulate siya and nagkaroon tayo ng equation with one variable with still being equal to the first function kasi ang y daw dito kasi ang y daw is equal to negative 2x plus 30. So just substituting it will give us the another function, the rewritten function 2x plus the quantity negative 2x plus 30 equals 30. So an objective function is the real valued function whose value is to be minimized minimize or maximize over the set of feasible alternatives. In short, the objective function is the function that aids in the optimization of values in the situation. So ito yung need nating ma-manipulate in the solving process which in this part dito na tayo gagamit ng application of derivatives doon sa objective function. So to perform optimization in calculus, here are the overall general steps that apply to each math problem. So ito yung mga collective and effective steps na pwede natin magamit kapag nasa-solve tayo ng problems about optimization. Number 1, or the first step, sketch visually the graph illustration of the physical situation if applicable. Madalas ganito yung nangyayari lalo na sa mga geometry problems or pwede rin ma-apply siya sa problems such as numbers or like yung linear equation mismo or trigonometry and economics. Pwede siya actually sa economics lalo na if you're dealing with the maximum or minimum prices that can be applied in a situation. So parang ganon. Also note that any physical restrictions determined by the physical situation. So parang ito na yung part na magsasa tayo ng interval sa function. So like parang halimbawa, the possible value of x could just be between 0 and 12. Could just be between negative 12 or 0. Parang ganun yung physical restrictions. Now next is set up the equations. Write an equation that relates to the quantity you want to optimize in terms of the relevant variables. So parang if kailangan mo ng length and width, you have to set up the equation using the variables length and width. Same goes with like random variable x, y, r, s, or t. Usually t denotes time. If necessary, use the other given information to rewrite the equation in terms of a single variable. So, dito na yung part na magmamanipulate tayo ng mga variable para mas madalian tayo sa pag-solve ng derivative or pag-solve ng mismong value ng kailangan nating mahanap. Now, maximize or minimize the function. So, dito na tayo magpapasok sa derivation. Take the derivative of your equation with respect to your single variable and find the critical points. Determine the maxima and minima as necessary. So, parang after natin ma-derive, syempre mababawasan yung degree ng function na yun. So, mas madadalian na tayo maghanap ng critical points which is either the maximum or the minimum points of the derivative. Remember to check the endpoints if there are any. So, this will bring back to our second steps. Dun tayo sa finding the physical restrictions or like baka may mga interval na dapat doon ang papasok yung value ng x or value ng hinahanap. Now, finalize the answer by checking and writing the final answer. So, yan ang general steps para ma-optimize natin ang isang function based sa situation given and based sa given values. So, punta na tayo sa application. Marami actually, napakaraming forms of problems na maaaring makapasok sa optimization. So, parang find the maximum value of chuchu, find the minimum value of chuchu, and pwede pang, what's the maximum blank? Like, maximum area, maximum height, minimum volume, minimum income, maximum rent, maximum wage, parang gano'n, minimum wage, and such. So, may anim na problems nandito na like parang dun lang yung pinili kong examples kasi kung kukunin ko every aspect ng possible, baka matagalan tayo. So, ito lang yung anim na pinaka-fundamental sets of problems sa kadalasan makikita natin na maaaring ma-apply ang optimization as a concept in calculus. So, number one, find two numbers whose sum is 70 and product is a maximum. Ito yung isa sa mga most common applications na nakikita ko rin as I browse some sources. Ito yung pangunahin talaga na makukuha nating example. So, finding na about two numbers and like getting their maximum product difference. Maximum product like ganun, minimum difference, maximum product, minimum quotient, parang ganun. So, let's set up values. So, let x and y be the two numbers. Let s be the sum of x and y, and let p the product of p and y. So, setting up the functions, we have 7x s, which is the sum. S is equal to x plus y, the sum of two numbers. And since the given sum is 70, we have 70 equals x plus y, which we can consider as the constraint function. Remember pala na maaari na natin hindi explicitly ma-determine kung saan ang objective or saan ang constraint function, basta meron tayong function na magagamitan ng derivative. Ang importante dito talaga yung objective function, pero kahit hindi mo na explicitly sabihin na yun yung objective function, okay na siya as long as you have nga the equations. So furthermore, we have the objective function. Dito, maaari natin siyang malahad talaga. So we have 70 equals x plus y. Ay, mali. We have p equals xy, which is the product of x and y. Walang value ng p, and yun yung hahanapin natin value ng p. So now let's dig in the value of y in the function. So parang hanapin natin yung value ng y in terms of x. We have 70 equals x plus y. So y equals 70 minus x. So furthermore, 70 is equal to x plus 70 over x. Now, y is equal to 70 minus x. P is equal to x plus y. Gagamitin x times y. Gagamitin na natin yung isang function. I-apply natin dito yung value ng y, which is 70 minus x. I-substitute natin siya. So, we will now have 70 p is equal to x multiplied by the quantity 70 minus x, which is in turn p is equal to 70x minus x squared. So, now we have p is equal to 70x minus x squared. Pupunta na tayo sa deriving the variable. So, let's differentiate p. Ito na yung application of derivative. P is equal to 70x minus x squared. P prime is equal to 70 minus 2x. So, after natin, ito na actually yung derivative niyan, yung p prime is equal to 70 minus 2x. Pero para magamit na natin siya, let's set the derivative to 0. So, since p prime is equal to 70 minus 2x, 0 is equal to 70 minus 2x. Find now the values of x and y. So, 0 is equal to 70 minus 2x, 2x equals 70, x is equals to 35. May value na tayo ng x, which is 35. Going back, 70 is the value of y is equal to 70 minus x, y is equal to 70 minus 35, and y is equal to 35. So the numbers in the problem, the numbers are 35 and 35, and these are the numbers that are equal to that have the sum that is equal to 70 and that can give the maximum product. So number 2, find the positive numbers with a product of 144 and whose sum is the minimum. And another, what is the minimum product? Similarly, let x and y be the two numbers, let s be the sum of x and y, and let p the product of x and y. So p is equal to x plus y, x times y, 144 is equal to x times y, which is the constraint function. Ito yung another function na nahanap natin na halos complete ang given. And we have to find the sum of x and y. So we have s is equal to x plus y, which is subjective function. Yun yung kailangan nating hanapin. Now let's try to manipulate the one function. 144 is equal to x plus y is equal to 144 divided by x. And since we have now the value of y, which is 144 times divided by x, we can manipulate 144 into 144 is equal to x multiplied by 144 divided by x. So let's go back to the objective function. S is equal to x plus y. X is equal to x plus 144 over x. So let's now derive the function. S is equal to x plus 144 divided by x. Rewriting this will give us s is equal to x plus 144x raised to negative 1. Deriving it will give us s prime is equal to 1 minus 144x raised to negative 2. Equating the derivative to 0 will give us 0 is equal to 1 minus 144x raised to negative 2. And by further solving for the value of x, we'll now have 1 is equal to negative 144 over x squared. X squared is equal to 144, and further solving it will give us x is equal to plus minus 12. Since the problem asks for only positive numbers, let's disregard the negative 12. So we'll now have x is equal to 12. Going back, since may value na tayo ng x, let's now find y using the value of x that is found. Y is equal to 144 divided by x. Y is equal to 144 divided by 12. Y is equal to 12. To finalize, since kailangan pa natin mahanap yung sum, let's add x and y, which is 12 and 12. S is equal to x plus y. S is equal to 12 plus 12, s is equal to 24. So the two numbers are 12 and 12, and the minimum sum is 24. Next problem, the perimeter of a rectangular field is 20 meters. If the area of that field must be maximized, what should be the dimensions of the field? So dito na tayo magsimula magpunta sa illustrating the problem. So, pasensya sa aking drawing. So, yan ang aking makakaya. So, we'll now have the rectangle, the length which is x meters pa lang, and width which is equal to y meters. Let x be the length and y be the width. Let B be the perimeter of the rectangle, and let A be the area of the rectangle. So, setting up the equations, we'll now have P is equal to 2x plus y. So, galing siya sa alam na nating formula ng perimeter, which is 2 length plus 2 width. So, yun. Kaya we'll now have P is equal to 2x plus 2y. Since may alam natin yung product, which is 200 meters, perimeter, let's substitute it. We'll now have 200 equals 2x plus 2y. So, now, ang mission natin is mahanap yung area. Hindi pa natin alam yung area. So, yun yung hanapin natin. So, we have a is equal to xy. That's it. So, let's continue solving. Hanapin natin yung y in terms of x para sulat lang natin yung equation. Ito an equation with one variable. So, 200 is equal to 2x plus y. 2y is equal to 200 minus 2x. Y is equal to 100 minus x. Substituting the value of y in the perimeter side to the y value in the area side, we have a is equal to xy. A is equal to x multiplied by 100 minus x by the quantity 100 minus x. A is equal to 100x minus x squared. So, meron na tayo nakita, na set-up na natin yung equation dun sa area part. Ito yung objective function. So, dito na tayo pumunta sa derivation. So, important na kapag na-setup na natin yung objective function natin into an equation na parang kaya na natin ma-solve, na kaya na dapat ma-solve, and madali na ma-solve, and possible na ma-solve, yun yung important, possible na ma-solve, saka na tayo mag-derive. Important dito is yung possible na silang ma-solve kapag na-satisfy na yun sa tingin natin. Now, let's proceed to deriving the function. So, a is equal to 100x minus 2x squared. A prime is equal to 100 minus 2x. Na-apply na dyan yung derivatives, yung product rule. And let's set up the derivative of the function into an equation with the equal to 0. So, a prime will replace to 0. 0 is equal to 100 minus 2x. Let's solving the value of x. We have 0 is equal to 100 minus 2x. 2x is equal to 100. X is equal to 50. May value na tayo ulit ng 50. So, going back to the y variable, finding it will give us 100 minus x. X is equal to 50, so y is equal to 100 minus 50, and y is equal to 50. So, the final answer dito, the dimensions of the rectangular field that can produce the maximum area is 50 meters by 50 meters. Next problem, an open top box is to be made from a 24-inch by 36-inch piece of cardboard by removing a square from each corner of the box and folding up the flaps on each side. What size square should be cut out from each corner to get a box with the maximum volume? So, kailangan na rin ito nating i-set up yung equation and i-visualize yung problem. So, let x be the side length of the square to be removed from each corner, and then let the remaining 4 flaps can be folded up to form an open top box. So, kaya siya dito, x, binabawasan siya ng mga x inch sa gilid kasi nga daw, sabi sa problem, square cuts sa gilid para ma-fold natin. So, if 24 inches ang width and 36 inches ang height, magkakaroon tayo ng length sa box na 36 minus 2x kasi dalawang x yun, and the width that is equal to 24 minus 2x inches. So there are two figures for this figure. The first one is a rectangular with the sides 24-inch and 36-inch, and with each corner having a square of side length x taken out of it. So ito na pala yun. In the second picture, there is a box with the side lengths x in 24 minus 2x inch and 36 minus 2 inch length dimensions. So the problem aims to maximize the value of the box or the variable v. So it is known that the volume of the box is v is equal to length multiplied by the width multiplied by the height, where L, W, and H are the length and width and height respectively. From this figure, we can see that the height of the box is x inches kasi yung tinapyas natin sa 2D. The length is 36 minus 2x inches and the width is 24 minus 2x inches. So setting up the equation, setting up the length, the width, the height, we'll have v of x is equal to the length 36 minus 2x multiplied by the quantity 24 minus 2x, which is the length, and multiplied by h, which is the height. Simplifying the equations or Distributing the terms will give us v of x is equal to 4x cubed minus 120x squared plus 864x. So ito yung another part na kailangan natin magkaroon ng restriction sa physical situations, like parang hanapin natin yung value ng x kung saan lang siya possible mahahanap. So let's set up intervals. So since v of x is a continuous function over the closed bounded interval 0, 12, v must have an maximum value and an absolute minimum. However, since v of x is equal to 0 at the endpoint and v of x is greater than 0, for 0 is greater than x, 0 is less than x, is less than 12, the maximum must occur at a critical point. So like parang ano lang siya, dimensional analysis, so by inspection. So ito yung ating na-formulate na idea sa ating mga ulo. So the derivative, let's go back to the function. The derivative of the said function is v of x is equal to 4x cubed minus 120x squared plus 864x. V prime x, so na-derive na natin. V prime x is equal to 3 multiplied by 4x squared minus 2 multiplied by 120x plus 864x raised to 0. So, the simplifying will give us v prime x is equal to 2x squared minus 240x plus 864. To find the critical points, let's set the derivative to an equation equal to 0. So, ito na yun na yung v of x natin, yung v prime x, gagawin natin equation equal to 0. So, yung v prime x, gagawin natin siyang 0. So, 12x squared minus 240x plus 864 is equal to 0. Dito na tayo magsisimula sa paghahanap ng value ng x. So, ito na yung steps ng paghahanap dito. So, dividing both sides of this equation by 12. The problem simplifies to solving the equation x squared minus 20x plus 72 is equal to 0. Using the quadratic formula or any formula that you want, but since this problem use the quadratic formula, pwede naman siya. So, the critical points daw, according to quadratic formula, are x is equal to 10 plus or minus 2 raised to square root 7. Since 10 plus square root of 2 square root of 7 is not in the domain of consideration, so parang greater than 12 siya, the only critical point that will be considered is 10 raised to 2 square root of 7. Therefore, if the volume is maximized if we let x be equal to 10 minus 2 square root of 7. So, di ba ito na yung, ano natin, 10, ito na yung volume actually. So, ayun, we now have the value of x, which is 10 minus 2 square root of 7. So, let's go back to the first equation that we have from the start, which is v of x is equal to 4x cubed minus 120x squared plus 864x. Now that we have the value of x, let's substitute it to the equation. So, since we have substituted it na, so na-substitute na natin, we'll arrive in the final answer, v of 10 minus 2 square root of 7 is equal to 1825.296. So, like, simplify na lang natin, is equal to 1825. So, ito na yung maximum value. The maximum volume of the box is about 1825 cubic inches. Nag-work na tayo from the start. Ito na yung answer natin. Next, a rectangle is to be inscribed in the ellipse x squared over 4 plus y squared equals 1. What should be the dimensions of the rectangle be to maximize its area, and what is the maximum area? So let's draw the equations. Let's do the equation. Ito na yun. Sorry sa napakaganda kong drawing. So, yun. We can see the function of the ellipse. Ellipse na yan. The function of the ellipse, x squared over 4 plus y squared equals 1. And ito yung hypothetical dimensions ng rectangle sa loob na ito na nga yung isang point which is x, y. For rectangle, To be inscribed in the ellipse, the sides of the rectangle must be parallel to the axis. Yung horizontal siya. Let L be the length of the rectangle and W be its width. Let A be the area of the rectangle. So the ellipse x squared over 4 plus y squared equals 1 is drawn with its x-intercepts being plus or minus 2 and its y-intercepts being y plus or minus 1. So yun na yung given na yun. Kasi drawing kasi yun yung sinasabi na equation na x squared over 4 plus y squared is equal to 1. There is a rectangle inscribed in the ellipse with length L and width W, and the goal is to maximize the area of the rectangle inscribed inside the ellipse. The problem is to maximize A, and the area of the rectangle is A is equal to length times width. So our goal is to maximize A is equal to L times width. Let xy be the corner of the rectangle. Let xy be the corner of the rectangle that lies in the first quadrant. The length is equal to 2x and the width is equal to 2y. Going back na tayo sa formula ng perimeter. Since x squared all over 4 plus y squared equals 1 and y is greater than 0, y is equal to the square root of 1. So yun, y is equal to the square root of 1 minus x squared all over 4. So therefore, the area is A is equal to length times width. Alam na natin na ang length is 2x and the width is 2y. So A is equal to 2x times 2y. Furthermore, A is equal to 4x times the square root of 1 over 1 minus x squared all over 4. And therefore, A is equal to 2x multiplied by the square root of 4 minus x squared. So another inspection ulit tayo. From the figure to inscribe a rectangle in the ellipse, the x-coordinate of the corner in the first quadrant must satisfy 0 is less than x is less than 2. So ito na yung closed interval. Therefore, the problem reduces to looking for the maximum value of a over x over the open interval pala. Over the open interval 0, 2. Since ax will have an absolute maximum value over the closed interval 0, 2, consider a of x is equal to 2x multiplied by the square root of 4 minus x squared over the interval of 0, 2. So yun, parang in-apply na lang natin yung pag-apply ng interval para mas madali tayong mahanap ng maximum value. If the absolute maximum occurs at an interior point, then the absolute maximum is now found in the open interval. As mentioned earlier, a of x is a continuous function over the closed bounded interval 0, 2. Therefore, mayroon siyang absolute maximum. May absolute minimum din, pero ang mas important is yung absolute maximum. At the endpoints, x is equal to 2 and x is equal to 0, a of x is 0. Kasi yun yung given sa ellipse. Kapag x is 0, yung value ng e is 0. For the interval 0 less than x less than 2, a of x is greater than 0, so therefore the maximum must occur at the critical point. Dito na tayo ulit papasok sa pag-derive. Taking the derivative of a of x, haba-haba itong process, so let's just apply the concept of product rule, chain rule. We will be in the endpoint a prime of x is equal to the quantity 8 minus 4x squared all over the quantity square root of 4 minus x squared. Ito na yung derivative, and para mas mahanap natin yung critical points, find the value where a of prime of x is equal to 0. So actually, ito na yung part na i-apply na lang natin siya into 0. If x is a solution of the quantity 8 minus 4x squared, mali yung grouping. So actually, if x is a solution of the quantity 8 minus 4x squared, close, so yung squared pala applied lang sa 4x, all over the quantity square root of 4 minus x squared is equal to 0, it must satisfy the equation 8 minus 4x squared is equal to 0. Therefore, furthermore, kasi tayo, 8 squared is equal to 2. Thus, the possible solutions of the equation are x is equal to plus minus negative 2. However, since x is considered over the interval 0 to close interval, x is equal to square root of 2 and it is a possibility for a critical point. However, the point negative square root of 2 is not kasi nga wala namang positive value na kailangan. Ay walang negative value na kailangan. So, disregarded yung negative square root of 2. However, i-check pa rin natin kung yung square root of 2 is a solution. So, by checking the equation, we'll have a prime of x is equal to 8 minus 4x squared all over the quantity square root of 4 minus x squared. A prime of negative 2. A prime of the square root of 2 is equal to 8. The quantity 8 minus 4 multiplied by the square root of 2 squared all over the square root of 4 minus the square root of 2 squared. Pag sinolve natin siya, magiging siyang a prime of square root of 2 is 0. So, since solution siya, concluded that the quantity of square root of 2 is the only critical point of a of x in the interval 0, 2. Therefore, a of x must have an absolute maximum of the critical point of x is equal to square root of 2. To determine the dimensions of the rectangle, we need to find the length and the width. Balik na ulit tayo dun sa pinaka-umpisa nga na part ng equation. If x is equal to the square root of 2, since may value na tayo ng x, then y is equal to the square root of 1 minus the quantity square root of 2 squared divided by 4. So, sorry puro siya linear. So, isulat nyo na lang siya in a way na may visualized yung functions. So, y is equal to the square root of 1 minus 1 half. Y is equal to 1 over 1 half. Y is equal to 1 over square root of 2 pala. Yun. Ito na yan. So, alam na natin ulit yung value ng y. Alam na rin natin yung value ng x. Balik na tayo doon sa formula sa equation ng ellipse. And let's now maximize the area. X squared over 4 plus y squared equals 1. X squared is equal to 4 multiplied by 1 minus y squared. X squared is equal to 4 multiplied by the quantity of 1 minus the quantity of 1 ulit minus negative over the square root of 2 squared. X squared is equal to 2 and x is equal to square root of 2. Parang binalik na natin siya kasi alam na natin yung value ng y and para ma-check natin na equal yung value of x. Now, darating na tayo sa pag-substitute ng length. So, since alam na natin na square root of 2 yung x, we'll now have the length which is 2 square root of 2 and alam na natin yung value ng width which is 2 multiplied by the value of y which is 1 over the square root of 2. So, we'll now have the length of the width which is equal to the square root of 2. Punta ulit tayo sa area. The area is the length multiplied by the width. The width is square root of 2 and the length is 2 square root of 2. So, let's multiply it to the area. To get the area, we have a is equal to the quantity 2 square root of 2 multiplied by square root of 2 which will give us 4. Yun na yun. Area is 4. Oh my. So, the maximum area of a rectangle inscribed in the ellipse is 4 units squared. Yun na yung final answer natin sa problem number 5, which is ito. Yan na sa last part, sa last example natin for today. May relationship sa economics somehow. So, owners of a car rental company have determined that if they change customers P dollars per day, given a variable P dollars per day to rent a car, where there is an interval 50 is less than or equal to P, and P is less than or equal to 200, the number of cars they rent per day can be modeled by the linear function n of P is equal to 1,000 minus 5P. If they charge 50 pesos per day or less, they will rent all their cars, and if they charge 200 pesos per day or more, they will not rent any cars. So assuming the owners plan to charge customers between 50 per day and 200 per day to rent a car, how much would they charge to maximize the revenue? Given yung given yung closed interval, given yung function, yung linear function, na kailangan lang nating mahanap yung maximum value para sa kanilang revenue. Revenue is yung amount ng rent. So, let P be the price charged per day and per car, and let N be the number of cars rented per day. Let R be the revenue per day, and since meron na tayo ditong variables, ang problem dito is to maximize R. The revenue per day actually is equal to the number of cars rented per day times the price charged per car per day. May formula siya, so which is equal to R is equal to N times P. Alam natin yung N, yung function ng N dito, and alam din natin yung values ng P, so let's get on. Since the number of cars rented per day is modeled by the linear function, yun nga, yung N of P is equal to 1,000. Oh, okay. R of P is, wait. By the linear function, N of P is equal to 1,000 minus 5P. The revenue R can be represented by the function R of P is equal to N times P, which is equal to 1,000 minus 5P. Ito yung N and P na R. So, they're almost equal. So, we'll simplify the function to get the R of P, which is negative 5P squared plus 1,000P. Since the owners plan to charge between 50 per car per day, and 200 per car per day, the problem is to find the maximum revenue R of P for P in the closed interval 50 to 200 kasi like nagbigay na sila ng closed interval which is 50 and between 50 and 200. Since R is a continuous function over the closed bounded interval 50 to 100, it has an absolute maximum and an absolute minimum in that interval. And ang kailangan natin dito is the maximum value kasi yun yung tinatanong sa given. Haha, tapos na, joke. Now that we have set up the goal, let's now derive the function R of P is equal to negative 5P squared plus 1000P. Deriving this will give us R of P is equal to negative 10P plus 1000 by applying the rules of differentiation. Now to get the value of P, let us set the function to 0 where we should change the R of prime of P to 0. So we now have 0 is equal to negative 10P plus 1000, giving us 10P is equal to 1000 and P is equal to 1000. Therefore, the critical point is P is equal to 1000. To get the maximum revenue, actually tapos na yun. Tapos na yun na P is equal to 100. Tapos na yun as yung answer sa question. Pero to increase the answer more, let us find the maximum revenue. So R of P is equal to negative 5P squared plus 1000P. R of 100 is equal to negative 5 multiplied by the quantity 100 squared plus 1000 multiplied by 100. So we'll now get the maximum revenue, R of 100, which is equal to 50,000. So therefore the absolute maximum occurs at P is equal to 100 pesos, and the maximum revenue that we could get is 50,000 pesos. So that's it for our lesson for today. I hope that you have learned something from me as much as I have learned something new from this lesson. Then, habang sinusulat ko yung ibang questions or like, nintindi ko kasi like, I just got it from outside sources. So, ayun. I hope I have helped sa ng concepts about derivatives, and let's see each other next for the parts 2 and 3 of this module 6.